Alright, so today we are going to be solving with trig equations. So when we are writing out our work, we're going to make sure that we have the trig equations in our work. And we are going to be using SOHCAHTOA. So if you need a little reminder, we can put that at the top. Alright, so when you are solving with trig functions, the first thing I recommend you do is label your sides as the opposite, okay, the hypotenuse, and the adjacent side. The reason why it's helpful to label those sides is so you know what the corresponding trig function is. Okay, so you're going to set up an equation using the corresponding trig function. So you are going to set up an equation. I'm going to be looking for your equations. Okay, that's going to be your work. Using the corresponding trig function. So the corresponding trig function is going to depend on what sides you have and what sides you have to find. Okay, and you did this in geometry, so I'm hoping some of it will come back for us. And then you're going to solve for the variable. Okay, so we are going to be using SOHCAHTOA with right triangles. Okay, I'm going to draw the first right triangle for you. Okay, so this is going to be your triangle. This side is x. This side is 74. And then you are given that this angle is 30 degrees. Alright, so if I follow my steps, the first thing I'm going to do is label opposite, hypotenuse, and adjacent. That is always going to be labeled from the angle that you are using. So you can use the 30 degrees, or if you wanted, do you guys know what this angle is? 60, you could use that as well. So I'm just going to use the 30, so the opposite side is going to be x. The hypotenuse is 74. And that's my adjacent side. So what I'm given is H. What I have to find is the side with O. So if I'm looking at SOHCAHTOA, the side that has O and H is going to be the sine. So it's the sine of theta equals O over H. O and H are side lengths, and the theta value is your angle. So this is where you're going to plug in your angle measure. Okay, so what I need to see is you have this equation. The sine of 30 degrees equals x over 74. Okay, have to show that in your work. Now to solve for x, you're going to take both sides and you're going to do what with it? Multiply by 74. So you can either show me this, you can either show me the times 74, or if you want, you can just write x equals 74 times 30 degrees, because this is a pattern you're going to do over and over. And then we're going to calculate. Okay, so when you're doing this calculation, you are going to have to make sure your calculator is in the right mode. Okay, whenever we clear our calculators, the standard mode is radian mode. Okay, so if you go to the mode on your calculator, right here it says radian or degree. So I'm going to highlight degree and press enter. And then I'm ready to do 74 times the sine of 30. Okay, got 37. So based on that, what is the sine of 30? So I did 74 times the sine of 30 and I got 37. So what is the value of the sine of 30? 1/2, right? Half of 74 is 37. Okay, they are not always going to be such beautiful whole numbers. Okay, so you're using your trig function to find this value. We're going to label to the near, or we're going to round to the nearest 10 if we have to. And different questions will ask you to round to different places. Alright, then for B, we have an angle that's 45, a side that's x, and another side length that is 20. Do you guys remember you had special rules for 45, 45, 90 triangles? We're gonna actually review those next week. Okay, so again, we can start by labeling. We know this side is H, it's across from the right angle. If I use this as my 45, this is my adjacent, so I'm going to have my cosine. Okay, it's the cosine equals A over H. So you can just write the cosine of 45 degrees equals x over 20. This is just like what we did last time where we have to multiply. And like I said, you can just write this. You can write your original equation and then what you are calculating. Okay, that's all the work I need to see for those, okay? So cosine of 45, we can also just do times 20 this way. We are going to round this to the nearest 10 since it's a decimal. So this is approximately 14.1. Alright, you guys ready to try part C on your own? Alright, so I'd like you guys to practice writing out your equation. And then remember you're rounding to the nearest 10. Alright, so this was a little bit of a different setup, right? So when you did your opposite over adjacent, you have the tangent of 20 degrees is equal to O over A. So that would be 6 over X. So if you were solving it like we did here, remember how we multiplied by the denominator? If you multiply both sides by X, what are you going to end up with? Yep, X times the tangent of 20 equals 6. And then what would you do to both sides? Divide. Okay, so then you would have X is 6 divided by the tangent of 20 degrees. And then we will around that answer. Okay, do we remember some of this from last year? Okay, so if you want, when you notice the variable is in the denominator, if you just want to jump to this step, you can. Okay, if the variable is in the denominator, you're going to end up dividing. Your variable's in the numerator, you're going to end up multiplying. Okay, so that's a pattern that you'll notice when you've done this several times. Okay, we're also going to do some application problems today. So when you're doing story problems, I want you to make sure that you draw a right angle. So this is about a water skiing competition. The jump ramp is 19 feet long, and that goes from the water to the top of the ramp. Okay, if the angle between the ramp and the water is 15.1 degrees, it says what is the height to the nearest foot above the water that a skier leaves the ramp. Okay, so you are trying to find the height. So we can just draw a right triangle. The scale of your triangle doesn't matter much to me, but the more accurate you draw it, the more accurate your angle is going to be to your drawing. Okay, I just want you to make sure that you have a right triangle and you have it labeled correctly. So the jump ramp is 19 feet long. So if this is in the water, right, where is the water skier jumping off of? What part of the triangle? Yeah, it's going here, right? Whee! That looks like a big jump. Okay, so this is the length of the ramp. This is your 19 feet. Okay, it's not going here. This is your ramp, going up the ramp. Okay, and then it says 15.1 degrees is between the ramp and the water. So it can't be the right angle. It's going to have to be this angle, 15.1 degrees. Again, this is not to scale. And then you have to find the height. The height is always with a right angle. So this is going to be your height. And then from there, you can just label the side that's the hypotenuse. We know this side is the opposite side. So to solve this, I'm going to use which trig function? Yep. So it's going to be the sine of 15.1 degrees equals x over 19. Because the variable's on top, we are going to multiply those together. And it says to round to what here? Nearest foot. So that's going to be the nearest whole number. Okay, so I got 4.9, dot, dot, dot. So it's going to bump it up to 5 feet. When you have a story problem, you are going to have units, so make sure that you are using those units. Okay, so if it's asking you to round to the nearest foot, it's asking you to round to the nearest whole number. Alright, and then example 3 is about a biologist whose eye level is 6 feet above the ground, and the biologist measures the angle of elevation to the top of a tree to be 38.7 degrees. If the biologist is standing 180 feet from the tree's base, what is the height of the tree to the nearest foot? Okay, so some of you might remember what an angle of elevation is, because it is something you would have talked about in geometry last year. We'll do a little information box just to remind us what the angle of elevation is. So you would have studied the angle of elevation at the same time you studied the angle of depression. Does that ring a bell? Okay. Alright, so when you're dealing with the angle of elevation and depression, the angle always starts from a horizontal line. The angle of elevation is formed by an angle that is going upward. Okay, think about, you like to take the elevator to the top floor, right? We're going up there. And then depression. And so you're going to be going down from the horizontal. So this would be an angle of depression. So an angle of depression starts at the horizontal and goes down. Oops, I put elevator. And elevation. You can fix this. There we go. We just put the line there. Elevation and depression. So elevation goes up from the horizontal, depression goes down from the horizontal. Okay, so this problem has elevation. You will see angle of depression in your practice problems. Alright, so let's draw a biologist. I'm a stick figure kind of gal when I'm drawing the groups. Okay, and the eye level is where we have the information. So whose eye level is 6 feet above the ground. Okay, so I'm going to draw a right triangle. Ooh, that looks pretty good. Not even using my stencil. Oh, got you copied. Okay. So now we're going to label parts of the triangle. So the eye level is 6 feet above the ground. So I know from here to here it is 6 feet. The angle of elevation starts at the horizontal and goes up. That is 38.7 degrees. Okay, and it says that that is to the top of the tree. So you can put a tree in if you want. Alright, and then the biologist is standing 180 feet from the tree's base. Okay, so from here to here, this is 180 feet. And I have both of those in the same unit, so that is going to be helpful. And then what you have to find is what? The height of what? The tree. So you have to find this height. Okay, the height of the tree we know from here to here it's 6. We don't know what this length is, we'll call it x. If we can find out what x is, all we have to do is add that to the 6 feet. Okay, so the height of the tree is this part of our triangle plus the 6 feet. Okay, so we're going to set up an equation based on, this is the opposite side, this is the adjacent side. So opposite over adjacent is tangent. So 38.7 degrees is equal to the opposite over the adjacent. So to solve, I would multiply both sides by the denominator. I am rounding to the nearest foot for this. So 180 times tangent, 38.7. Gives me 144.2 dot dot dot. So x is going to be about 144 feet. So to find the height of the tree, just add 6 to that. So the height of the tree is going to be 150 feet. Okay, so we can use tangent to find x. Once we have that, we're going to add the 6 to it. All right, any questions about using SOHCAHTOA for solving the story problems? We're going to move on to the arc length. Let's see if you guys remember doing any of the arc length in geometry. So the arc length is for a circle that has a radius of r, a central angle, theta, and what does it specifically say about theta? The central angle theta is measured in what? Radians, which means when you plug this in, it's going to have to be in radians. Okay, and then the arc length we call S is the product of r and theta. So product means that you do what? That you multiply. So we are going to use the formula S equals r times theta. Again, that has to be in radians, so not degrees. And then they give you just a visual here. When you're finding the arc length, you are finding the length of this. Okay, the length of S. You remember that the radius is going to be the distance from the center of the circle to the edge. And our theta value is going to start here and then go up to our terminal side. Right, so for example 3, we are doing calculations using our formula. So we just have to find the length of the arc. We're going to round to the nearest tenth. Okay, so we're just going to use S equals r times theta. So we just need the r value and we need our theta value. So they give us r in the diagram. It is 3 feet. They also give you theta in radians, 4 pi over 3. If they gave it to you as a degree, you would have to convert it. So your S value is going to be 3 times 4 pi over 3. Now this one they ask you to round to the nearest tenth. Okay, other times they might ask you to find an exact value. If they do ask you to find an exact value, you would leave it like this. Because this one asks you to round it to the nearest tenth, that is what we are going to do here. Okay, I just want you to follow the directions that they give you in the problem. Okay, so 4 pi, if I round that to the nearest tenth, it's going to be 12.6. Okay, and the length is going to have a unit to it. So in this case, it is feet. Okay, you do have to make sure we are paying attention to the units. Okay, so for these story problems, we are going to include units. We're also going to make sure we are consistent with those. So in example 4, we have an application. There's a surveyor's wheel with a diameter of 30 inches. It completes 13/20 of a rotation. We have to find the total distance traveled in feet. And we just say to round to the nearest hundredth if necessary, and it will be necessary. Alright, so let's organize some of the information they gave us. The first thing is they tell you the radius, they tell you the diameter and we need the radius. So remember to find the radius from the diameter. All you have to do is cut the diameter in half. Okay, so the radius is 1/2 times 30, which is going to be 15. And they gave that to you in inches, so 15 inches is going to be your radius. Okay, so just like we did last time, we had R and then we found theta. So we have to find that angle of the rotation. One full rotation around the circle in radians is what? What's one full time around the circle? 2 pi. Yep. In radians, it'll be 2 pi. So one full rotation is 2 pi. But we don't do a full rotation. How much do we do? 13/20ths. Okay. So to find our value of theta, we're going to do 13/20ths times 2 pi to figure out how far we go. Okay, and we are going to leave this as an exact value for now, so we only have to round one time. Okay, so if I multiply straight across, 13 times 2 is 26 pi over 20. We can reduce that to 13 pi over 10. So when we are finding the value, we are finding the arc length, which will be 15 times 13 pi over 10. But because we are plugging in the 15 inches, we're going to have to do some conversions because they do ask you to find it in feet. Okay, so again, I'm going to keep this as an exact value. I'm actually going to reduce it because what goes into both 15 and 10? 5. So if I divide by 5, I get 3 here, 2 here. What's 3 times 13? 39. So 39 pi over 2 is my value of S. This would be inches. So now I have to convert to feet. So if this is how many inches I have, when you set this up, you know whether to divide or multiply because you want the inches to cancel out with that same unit. So you start with that unit, it needs to go on the bottom. So for 1 foot, there's how many inches? 12. Okay, so then we can just multiply this out. We can do the 39 pi divided by 2, and then divide that by 12. You can also multiply straight across. You can do 39 pi divided by 24. Okay, there are several different ways you can calculate this. And then it said to round to the nearest 100, correct? So 0.105 would be 0.11, and that would be in feet. Okay, you could also, if you just did 39 pi divided by 2 here, okay, and knew that you just had to divide by 12, you could do that as well. Okay, you can just show the dividing by 12. I just want to show you why we do that. Okay. Our next one is about a merry-go-round, and the radius of the merry-go-round is 6 feet. Romeo stands on the edge, and his sister pushes him around. How sweet. So how far does Romeo travel if he moves through an angle of 5 pi over 4 radians, round to the nearest 10? Okay, so we have the 5 pi over 4 radians that we're going to use. we have to find how far Romeo travels. Okay, and we're going to round that to the nearest 10th. So if we're trying to find how far they travel, we are trying to find S. We are given this as your theta. And then are we given R? What's our R value? Yep. Okay, so we can multiply 6 by 5 pi over 4. You can think of this as over 1, so we have 30 pi over 4. We're rounding to the nearest 10th, so you don't have to reduce that if you don't want to. So if we round to the nearest 10th, we get 23.6 feet. Okay, now let's look at part B. The setup of this question is a little bit different. It says, through what angle does Romeo move if he travels a distance of 80 feet around the circumference? Oh, and this says to write our answer as an exact value. Okay, so if it's asking you to find what angle, what variable do we use for the angle? Theta. So we are trying to find theta here. Okay, so we're still using our S equals R times theta, but now we want to plug a value in for S and a value in for R. The radius hasn't changed, so it's still 6 times theta. The distance of 80 feet around the circumference, that is your arc length. Now, if it says to write your answer as an exact value, when you divide both sides, if it doesn't go in there evenly, your answer is going to be a fraction. So 2 goes into both of those, so it'll be 40 over 3. And because we are using this formula, this is going to be measured in radians. So this is 40 over 3 radians. Remember, it's okay if radians don't have pi. Alright, and then the last example we're doing today is going to be about a clock, not the digital kind that we're used to. So you draw a clock in your last space, the kind you used to tell time in elementary school. You just have the clock, so you can move the hour hands and the minute hands. So we're going to find the radian measure of the angle through which the hour hand on the clock rotates from 4 a.m. to 6 p.m. Okay, so we're going to draw a visual. Well, it's okay if it looks more like Humpty Dumpty sat on a wall. Okay, so put 12, 3, 6, 2, does this class look better than mine? Mine has a problem with the battery. Okay, so it says to find the radian measure of the angle. So we're going to find the angle through which the hour hand rotates from 4 a.m. to 6 p.m. It doesn't, you can put, remember our minute hand is the longer one. There we go. So the hour hand is going to start here at 4 a.m. Eventually, it's going to end up here, okay? But because you're going from AM to PM, what do we know about the rotation? Yeah, it goes a full rotation all the way around, right? Okay, and it does that one time. Okay, so one full rotation is 2 pi. So we're going to have a radian measure that's greater than 2 pi. So I know it goes all the way around, right? It's starting here. It goes all the way around and then ends up here. So this is the angle that I'm trying to find. So really what I have to find is the angle from the 4 to the 6. I have to find this angle here. Do you guys have any ideas? There's how many hour increments in total? What do you mean the 14? Okay, let's see how many it has. So from 12 to 1, this would be 1, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 of these sections. Do I know what a full rotation is? 12 goes 2 pi. So how can I figure out what each little section is? Yeah, all I have to do is take the 2 pi and divide by 12, right? So if I do that, each little section is pi over 6. So it's pi over 6 between, let's say, consecutive numbers. Okay, so between the 4 and the 5 is pi over 6. Between the 5 and the 6 is pi over 6. And there's a couple different ways that you can think of that. You can add them together. Do you guys know what pi over 6 plus pi over 6 is? 2 pi over 6. Or you can also just multiply. Okay? So to find the value, you do the full rotation plus 2 times pi over 6. Or again, you can add them together. What does this reduce to? Yep. So 2 pi over 6 is the same thing as pi over 3 when you reduce. Okay, and then you can just get a common denominator, just like we did the other day when we were adding. Remember when we had to add 2 pi and subtract 2 pi? So 6 pi over 3 plus pi over 3 is 7 pi over 3. And we are very close to the correct answer. There's just one thing we have to remember. When you are doing angles on a grid, if you're on a clock, the clock moves clockwise, right? What type of angle is that? Yeah, so if it's clockwise, it's a negative value. So you're going to have a negative angle, so you're just going to put that in front. So it's negative 7 pi over 3.